In today's video, our topic is about Voronoi diagrams. So, by definition, a Voronoi diagram is a partition of a plane into regions that are close to each of a given set of objects. So, if we take a look at this diagram on the right of your screen, this is an example of a Voronoi diagram. So, to make it simpler for you, Voronoi diagrams are like a map. So a Voronoi diagram is like a map of an area, and you're looking to go to a certain direction. So let's now go over the terminology that are relevant to Voronoi diagrams. Now, let's look again at this Voronoi diagram on your right. So, the small black dots that you see, so this dot, this dot, this dot, so these dots are called sides. And the surrounding lines are called edges. So, this line, this line, this line, this line, this line, all these surrounding lines are called edges. Now, the colored areas, this dark blue, this light green, so all these colored areas are called regions. Now, the point where any two lines meet is called an intersection. So if we take a look at this line and this line over here, this point where these two lines meet is called an intersection. Now let's take a look at this line and this line again. So these two lines, they meet at this particular point, so this is called an intersection. So again, the small black dots are called sides, the surrounding lines are called edges, and the colored areas are called regions. And the point where any two lines meet is called an intersection. So let's think about it. So the whole goal is that any particular location within a region, so let's say, let's take a look at this brown region. So any particular location within this region is close or is closest to this black dot. So if I'm gonna name this dot by the letter C, so this is C. Let me write it in black. So this is C. So this point is C. So any particular location within this brown colored area or brown region is closest to this black dot C. So that's the whole goal of Voronoi diagrams. Now, if a point is located on an edge, so if I have a point over this line, then this means that this point is equally located between this point C and this point, let me call it B. So again, if I have a point that is located on the edge, on this straight line, this means that this point is equally located between the two sides C and B. Now, let's go over an example and see how can we construct Voronoi diagrams. Now, in this example, this is a Voronoi diagram. So this is the y-axis and this is the x-axis. I have 4 blue points which are called the sides, and all these sides represent burger places. So the burger places are A, B, C, D. So A, B, C, C and D on this Voronoi diagram represent burger places. And these burger places are located within a particular region. So we have the average number of burgers sold for each burger place. So for A I have 210, for B I have 122, for C I have 98, and for D I have 540. Now, how can we construct this Voronoi diagram? So Voronoi diagram is a whole series of perpendicular bisectors. So what we have to do is to draw perpendicular bisectors. So if I look at these two sites, site A and site C, so this burger place and this burger place C. So how can I draw this line? So basically this line is the perpendicular bisector between point A and point C. This line is the perpendicular bisector between the point D and the point B. So that's how we construct Voronoi diagrams. So again, to recap, Voronoi diagram is a whole bunch of perpendicular bisectors. So you have to figure out the locations of the sites, and then you have to draw the perpendicular bisector that will bisect equally these sites. Now, let's have, or if we have a new shop, a new burger shop that's going to open right here. So in this region. So this is the new burger shop. And I want to estimate the average number of burgers that this shop will sell. Now, we have something that is called the nearest neighbor interpolation. Now, this shop that's going to open soon is closest to site B, or to burger place B. Now, to estimate the number of, or the average number of burgers that this new shop will sell, I'm going to use the nearest neighbor interpolation method. So since this shop is closest to B, so it's within this region, so it's closest to B, so I need to look at the burger place B and extract from this table the average number of burgers sold at the burger place B. So if we take a look at this table, then we find out that the average number of burgers sold is 122. So using the nearest neighbor interpolation, the number, or the average number of burgers that this new shop will sell is equal to 122. So that's using the nearest neighbor interpolation method. So I hope that this lesson will help you understand the concept of Voronoi diagrams, and see you later.